All right, I have 11:45 on my watch, so I'm excited to get going on what we are going to cover today in this talk on advanced agentic AI models in Azure AI Foundry is specifically we're going to dive into some of the really cool, new, more advanced things like reasoning models and computer use agents. So I'm going to start by kind of talking about reasoning models, and then we're going to transition into computer use agents, and my amazing colleague Marco and our friend Cosmin is going to come up and talk about those, okay? So to begin, let's kick off with reasoning models. So you guys may have been hearing a lot about reasoning models over the last year or so. This is kind of a new breed of models. How many people in the room have played with reasoning models before? Nice. Okay, so a lot of you have the good foundation, so we're in a good spot. So what is interesting about reasoning models is that they can solve problems that are just an order of magnitude more complex than what we could do with general LLMs. And the secret behind what they're doing is a chain of thought reasoning under the covers that allows it to get to more complex answers. And I want to show you that in more detail. But what that enables is all kinds of scenarios of things that we couldn't do before. So it's very good at generating small programs like end to end. It can compare like documents in detail with like very, very nuanced data, like give me the differences between these things. And then just kind of find larger patterns of insights in just a wall of text. And so what I want to do for you today is kind of raise the bar and make sure you understand the level that these things can operate at. So I'm going to try to give you very concrete examples of the kind of problems that you can solve with reasoning models. And then you can go out to the amazing Azure AI Foundry, and there's a very comprehensive list here of all of the models that are specifically reasoning models that are available on Azure AI Foundry today from the model catalog. So you can see a variety of options from Microsoft, from OpenAI, from DeepSeek, et cetera, and many others. All right, so just taking a step back, I'm saying that the secret behind reasoning models is something called chain of thought. So let me just pause and do a quick chain of thought explainer for those of you who aren't familiar with it. And this is actually the chain of thought explainer that I used like 2 years ago. So I am working, this is a very, very old model. The reason I have to use a very, very old model to show this is because the new models can get these things right like out of the box. But with older models, they weren't quite at the level that they could solve problems like this yet. So what I have here is a simple math story problem. Janet's ducks lay 16 eggs per day. She eats 3 for breakfast and bakes muffins with 4. So she uses 7 every day. She sells the remainder for $2 per fresh egg. So 16 minus 7 is 9. $2 per egg makes 18. So the correct answer should be 18. It gets 10. That's wrong, right? So not correct. Now, I'm going to use the exact same model. I'm not changing any model parameters. Everything is exactly the same. The only thing I am changing is my prompt engineering to include few-shot examples where instead of just answering the question, I'm talking through it a little bit better and guiding the model in how to pull relevant details out. So if you look there, when there's that question about, there's 3 cars in the parking lot, 2 more arrive, how many cars are there? Instead of just answering 5, it says, well, there's 3 cars already, 2 more come, so 3 plus 5 is, or 3 plus 2 is 5. The answer is 5, right? So it's talking through that logic, pulling forward those relevant details, and so what that enables is just being able to keep track of those details a whole lot better, which can empower more complex answers. And notice that in this case now, the second time around, it did get the correct answer of 18. Same model parameters, everything else exactly the same. It was just that chain of thought reasoning that enabled it to get there. And I've actually run this. You could question me. I would question me if I were sitting in your place. OK, Jen, that's a video recorded. So like, does that do it consistently? Or did you cherry pick an example? It consistently would get it right. I ran this one live a million times. I would run it live for you now, but these models are so old that no one has them anymore. But this is kind of what chain of thought can empower. Does that make sense? That's why this is actually working. OK, so now what we get with reasoning models is instead of me as the dev or any user of these large language models as a prompt engineer using the models, instead of me having to get it to do the right prompt engineering, with reasoning models, it's doing that for you under the covers, okay? So let me take an example and walk you through a few of them. I do want to specifically highlight 5.4 with reasoning. The reason is that's one of our newer ones, so this is more in the small language model category. And what's nice about that is that now there's a small language model option here that's from Microsoft. And so I'm going to use this 5.4 with reasoning example to show you a little bit more depth on what exactly they can do. But I exercise for the reader. I would love for you guys to check out the blog post, check out the technical report, all of that great stuff. And then what I want to do right now is let me show it to you on GitHub Models. We can see it real quick. So I'm going to jump over to my machine, and I'm going to show you here what makes a reasoning model different from a general LLM, large language model. Let's do something like that. So I'm just using GitHub Models here. Notice here that it is using 5.4 reasoning. And notice there's this little think section. So what it's doing is this is some of the chain of thought that's happening under the covers. And it is ruminating on this answer. It's using information from its system prompt. It's thinking very hard on like, what are the things, how should I format this? What should this look like? What are the things that are important? It's organizing its thoughts a little better. So one of the other things you can pull out of this is that reasoning models do take a little longer. They are able to come up with more sophisticated answers, but the trade-off there is a little bit more latency and more tokens, so they are a little bit more expensive as well, okay? So that's something that I encourage you strongly to think about as you're moving forward, and we're gonna talk about some more techniques to help you with that later on in this talk. All right, so it has, is it ended? It hasn't ended, oh, there, the thinking end, you see the end think tag just scrolled by right there, and now it's actually giving the answer of, hey, it does explicit chain of thought reasoning, and then some other things that can be really good about reasoning models. It's giving an answer for me there. Okay? So let's jump back to here. We saw 5.4 as one example. Okay, so now I want to give you a sense of like, all right, that was kind of a simple question I asked it, like give me the difference between these models. That's not what you would really use a reasoning model for. So let me give you an example of a real problem that I used a reasoning model to solve. This was the first one I tried in some early testing that I was doing for the SLT on how, I think it was with O1 preview initially, and just looking at like the kind of problems that they could solve. So here is the problem I threw at it. I have 3 kids. They are all in different grades. One of them is graduating elementary, one of them is graduating middle school, and one of them is graduating high school this year. So they are just like dispersed in their age groups. In my area, they have summer camps, but it's like, it's not a simple thing where you just sign your kid up for summer camp and then it's like a one camp for the whole summer, which would be lovely. Instead, they have like all these weekly summer camps where it's like pottery on this week only. Now there's chess club this week only. And so I have to create this insane matrix of like 3 kids by every week of the summer and like what camp works for what kid when. So at its essence, I know that sounds like a trivial, maybe like, oh, mommy problem, but like this is an insane constraint satisfaction problem, okay? At its heart, that's what we're dealing with. So I gave it a prompt that looked like this. I said, hey, I want you to plan a weekly schedule for me, all 3 of my kids for this summer. I want them in camps most weeks. Give me 2 weeks off for summertime, so I'm adding that constraint too. I want 2 weeks when my husband and I can take the week off and we're all together as a family. Here's information about each kid. One kid likes baking and dance, another likes reading and writing and soccer, another one likes martial arts and video games. And I want a different class each week. The output should look, I explicitly tell it what I want the output to look like. Give me a matrix of each week of the summer by each kid and then what they're doing. And then here is the summer brochure. And let me actually jump over to and show this to you guys live. But that's what the summer brochure actually looks like. And as you can see, there's a lot happening there, right? There's bolded text, there's font changes, there's pictures embedded, like there's just a lot of stuff. And what I did is I actually did this as a text-only input, so there is support for image going in now. But when I first did this, I did it only with text. So let me just show you that. Let's just get into it, you guys. So I'm gonna jump over here, back to my machine. So this is what the thing actually looks like, okay? So this is like 12 pages of a catalog with all of these different things. And then what I actually did to form the prompt, and I'm gonna make this prompt available for you guys so you don't have to take my word for it. You can run it yourself a million times on different models and see how it does. But I have the prompt that I just showed you, and then basically I just took this entire thing, all of the things, and just did Control-C, and then I came over here and I did Control-V, so I just pasted like a text dump. But think about what we're losing here, because like when you and I look at this, like we see like color changes, there's a bigger font here to tell you that this is a title, there's just a lot of information that's actually being lost. So I think that makes that even more impressive, that the model with like even without the formatting, with just like junk that looks like this, like just spewing at it, right? Where it's hard to tell like where does one start, the next one stop kind of deal. It's still able to do this. So now let me show you, this is something I ran this morning. And this is using O4 Mini in the Azure AI Foundry, woohoo. And let's just check some of this. So I'm gonna actually check the Tori level. So just a quick look, it looks like, so this is 12th, 8th, and 5th grade. This is their ages is first, and then the grade output right here. So at a quick glance, all of these look like they were placed in 12th grade classes. All of these are in 8th grade, which is where she belongs, and all of these are in 5th grade, which is where he belongs. So from that quick parse, it actually looks amazing. And now if I go, let's just do one quick verification. So I'm gonna check her because there's only like one page of stuff for the, this is 9th, 10th, but this is 9th, 10th, 12th, there's only like one page of stuff. They don't have much for high schoolers. So if we just go and verify, we can see that the week of July 8th, they put her in fashion design. Fashion design does actually exist, and it is the week of July 8th. No hallucinations there. Baker's workshop on the 22nd, so we had time off here. It shows one family time here. 22nd, which is the Baker's workshop, and that is the 22nd, correct. Here, microscopy for the 29th, and that's right here, 29th. Yes, that's correct. And welding, and then nothing offered the 19th. So welding the 5th and nothing on the 19th. So if we go back and check that, welding the 5th, and then yes, there is nothing offered the 19th. So no hallucinations. You guys! Like, how amazing is that? Like, do you know how long that takes me every year to sit down and plan all of these stupid camps for them? It takes forever. So, like, this is the level of thinking you should be at when you're thinking about how do I use my reasoning models, okay? So they can kind of do these insanely complex things because when you think about what's happening under the covers with chain of thought, it's pulling forward those little details and bringing them in, and so it's able to come out with more complex answers. Okay? Does that make sense? Cool. All right, so then the next question I would ask if I were you sitting in the audience is, okay, Jen, so yes, that did an amazing job, but what about like GPT model? Could it do the same thing? So good question. That's exactly the right question to ask. So let me show you the exact same thing, and now I'm running it using the latest state-of-the-art for a non-reasoning model, okay? And if we just do the same thing where we look for this, Tori, the week of July 15th, in the run it did, it put her in Song Studio for the 15th, and so if we go here, there is no Song Studio. If we look for Song Studio, it is, dun, dun, dun. It is for 7th and 9th graders. Tori's in 12th grade. That would not work, so that's not helpful. Same thing with, Yeah, Baker's Workshop, I think, is, well, it's not that. It was called New Something, and it's not, I think it was that week, but that's saying Potter Studio is also, Baker's Academy I don't think exists, but let me do Potter Studio and then the baking things. So Baker's, yeah, Baker's Workshop, or no, sorry, that one is the good one, but that's not what they said. They did Baker's Academy. So Baker's Academy was here for the 5th, and that is also a 8th, not the right grade level, so that was wrong. So you can go through and verify this at your leisure. Feel free to rewind the thing. But it can't solve the problem, all right? So that's kind of the type of things you should think about when you're thinking about when would I use a reasoning model. All right, so I kind of showed you all that. Now the downside of what you saw, so comparing it, I will say non-reasoning models are a whole lot faster, right? So because it's doing that chain of thought and it's deliberating and it's thinking very closely, they do respond faster. So the thing that I want you to think about for that is, if that's the case, like, don't use a reasoning model if you don't need one. So you're getting great power, but the trade-off is that it's going to take a little longer, it's going to be more expensive. So you want to use the right model for the job, okay? So we just saw here in the example with a non-reasoning model, it actually, you guys didn't see it running live because the non-reasoning takes a little bit longer. It takes a few minutes. I didn't want you to have to sit and wait. So I ran that in advance for you, but with the non-reasoning model, there were so many errors in stuff that it was not helpful. All right? So those are the things I want to talk to you, or I want you to think about. So think about that summer scheduling problem when you're thinking about when would I use a reasoning model. Here's a couple more examples I've used reasoning models to solve. And then I've made all of these available to you in a GitHub repo as well that I'll share on the next slide. So if you want to go through and don't trust me, kick the tires, try these things for yourself, you are more than welcome to. So the first example was code-based changes. So this was a fun one. I actually went and grabbed one of my favorite APIs, which was the Azure Content Safety API. It was one of the ones to detect grounding or something like that. And I gave it a version that came out like a year ago, and I actually did, and then I did a version that came out later. And I was running it on a model where the training data cutoff was October 23. So I actually chose a time like after October 2023, like a release that was afterwards. So there was no way it could get it from the training data, right? So I knew that like it would have to be able to actually think and reason this out. And I asked it, using the provided documentation below, summarize the key changes between these two API versions. And I copy and pasted from the docs page this version of the API, like paste, this version of the API, paste, just dumped it, like this was straight HTML from the doc site. And then I asked it to craft a blog post announcing the changes for an audience of software developers. It did an amazing job. It actually caught all of the differences that I had caught, and it actually caught like one or two that I hadn't noticed as well. And then I went back and verified, I was like, oh wow, it did. So it did a really, really good job with that. Agentic workflows was another thing I was testing, like how would it do with function calling and things like that. One thing I will say is that the reasoning models have gotten better with function calling. The original like 01 and the kind of the first round of them, I didn't think they were great at function calling when it was first added. Support has improved, so if you look at some of the later reasoning models, if function calling is important to you, like look at your 03 minis, your 04 minis. But for agentic workflows, I did a test where I said, you're driving a Minecraft character, and your goal is to craft a diamond sword. I apologize to people who don't play Minecraft because I know that makes no sense to anyone else. But basically, I had it. I gave it some functions, like, here's the things that you have possible, like build a plan for me. Wander around, punch things, smelt things, craft things. And then it actually did a very, very good job coming back and giving me the exact things that I would need to do to make that happen. And I worked out the Minecraft math, like this one log equals like 4 planks and all of that kind of stuff. So I did the Minecraft math, and it actually was worked out perfectly, which was really great. One thing is it did forget a little extra, or it said not explicitly in the steps, but it told me later that I needed to have it work in or I didn't have enough coal for smelting. It said afterwards, like, make sure that you have extra wood or coal. So it did say it, but it didn't include it explicitly in the steps. So I'm gonna like minus half a point for that one. And then I also did a productivity example where I used, I said check the football schedule against my calendar. I copy and pasted football schedule from the web, and then I took the my calendar, and in ICS, I exported my Outlook calendar and just dumped all of the stuff, and then dumped that as another huge wall of text in there, and it was able to find conflicts, which was incredible. So really, really, really strong examples of things where you have a lot of nuanced data, and you need to find things in it. Like reasoning models absolutely shine in those scenarios, okay? All right. Now, one thing I do want to show you super quickly is I'll jump over here just for 2 seconds and show you this code base. So this is I was showing you this thing earlier, but if you just go actually to github.com/JenniferMarsman/O1analysis. This one is public. I did this originally for O1, but you can just update it, and it works with other reasoning models as well. You can still run it with O3 Mini, et cetera. But this has all of the examples in here in a Jupyter notebook. So you can run all 4 of those examples, the summer scheduling problem, and then the document comparison, the Minecraft one, and the calendar, find the miss of my calendar. All of the stuff is in there, so try it yourself and feel free to just play and see how amazing they do. And then compare it with GPT, with other models, right, with non-reasoning models, and you can see how it does. Okay, so that is that. Now, let's jump back here. Okay, then the counterpoint I want to make is you guys have, hopefully I've convinced you of the power of these reasoning models and the amazing things you can do. But what I don't want you to do is be like, yes, these things are so amazing. I'm going to go and rewrite all of my systems to only use reasoning models. No. If you are doing just a simple back and forth chatbot, it's actually going to run slower, right? Because it's going to have this long internal monologue about the best way to respond, before it comes back. And if you want something where, your user is chatting and says, hey, I need help with this kind of thing, you may not need the power of a reasoning model. So I just want to make sure you kind of see the other side of that trade-off, that it is going to take longer, it's going to be more expensive, so you may not always need it. So let me give you an example here, and the other models have continued to improve as well. So this is an example of a question that it actually does just fine on both of them. So let me actually show that to you here. I'm going to jump over and use, in this case, I'm going to use GitHub model comparison. So I'm going to run here. You guys can see this? Great. OK, so right now I have, let me grab my word problem. So I'm going to use this. So this is just a simple story problem that's probably upper elementary level. I'm going to paste this plain text so it doesn't do it as an image. OK, so now I'm going to run using a non-reasoning model that's state-of-the-art and a reasoning model that's state-of-the-art. So it's a story problem. The correct answer is 1100. I've pre-computed it for you, OK? So what you should see is, on this one, boom, you see kind of the difference. GPT-4.1 Mini finishes a lot faster and was done. And this one actually took a little bit longer. So consistently, this one will be, but they both got it right. So in this example, you don't need the power of a reasoning model. It was able to handle it okay. So what I'm trying to tell you is look at your scenario, look at what you're trying to do, look at what your customers are trying to do, and don't use a reasoning model if you don't need one. And the other models are getting very good as well. So you want to use the right model for the job and make sure that you're always doing that, because they are going to take a little bit longer. So that's the other kind of thing to look at. But, oh my goodness, the things that they can solve. OK? All right, so now jumping back. So the last thing I want to mention is, OK, Jennifer, you just taught me, I saw that there's this nice provider where I can see back and forth what is possible. But the thing that I want you to do is, you guys may have seen yesterday, model router, yay! So what this is giving you is, I just kind of said, what I just taught you, here's reasoning models, here's non-reasoning models, here's what they're each good at, so that you have that understanding and knowledge. But if you are like, I don't want to deal with that, or my things are so complex and sometimes they're reasoning and sometimes they're not reasoning, how do I know what to do? I wanted to make you aware that yesterday we did actually release something called the model router. And we don't have time to cover it in this talk, but it is going to be covered in that one, so I want to point you to that one and go to that one to get an in-depth demo and such on model router. But what that one will do is take your query and then dynamically route it to the right model at the time based on the complexity of the query. So I just wanted you to have that as a tool in your toolbox as well, but now you know like what each of them can do. So feel free to check out the docs and go to that session tomorrow. All right, so you saw really amazing don't update everything because they are slower and more expensive and such, but oh my goodness, you saw the power of the kind of things a reasoning model can solve. So I hope I've taught you a little bit and made it clear like how you can use them in a very effective way. So go try out all of the amazing lists that I showed you at the beginning of reasoning models that are available on the Azure AI Foundry catalog. I've also left some customer case studies as hidden slides that you guys can grab from the deck later. And now I'd love to introduce my colleague, Marco, out to talk about computer use agents.
All right. Thank you very much, Jennifer. Hello, I'm Marco Castellano. I'm VP Products of Core AI at Microsoft. And through the wonder of AI, I'm going to unlock my computer with my face. All right. So I see a lot of faces in here that I know. And for those of you who know me, you know that I love messing with these new computer use agents, or I'll call them CUAs. So these things are pretty powerful. And so what we're going to do now is we're going to explore a couple of different types of CUAs and look at the kind of differences between them and how they operate. And this story actually starts, well, this little story starts here in Fabric. So here I am in the Fabric data agent. And you may have seen this one before, but basically I can select a subset of my lakehouse, and it creates this conversational interface over that. I plug that in turn into this here Foundry agent. So this Foundry agent is going to go find me a customer with a late delivery. You see it's connected to this Fabric data agent. This Foundry agent is the second agent in my chain, and because it does take like a minute for it to come back with this result from Fabric, I preloaded it over here because the result of this is actually the input to my third agent. And this is where the computer use agent is going to come in. So I have this delivery company. And, oh, this one wants my input, so okay, go. I told you to go ahead and go. Now, this is my computer use agent. And this one here is using, this is the Responses API. So this is in Azure OpenAI. I'm using the computer use preview model, as you can see here. This computer use agent can control an entire computer. So I have connected this to a Linux VM, and I'm running a Linux VM in here, and in that Linux VM, it's able to operate the browser. But actually, it's able to operate really any application in here. And the idea of these computer use agents is that they can reason through this stuff, like when a cookie pop-up shows up or whatever, it can kind of reason its way through it. Now, here's a key thing to know about computer use agents. They are not fast. Now, this one is actually, today, it's operating a little faster than usual, to be honest. It usually actually takes a little bit longer than this. They're not the fastest thing in the world, and the reason is it's sending screenshots back and forth and back and forth and back and forth. With every click, with every operation that it makes, it's sending these screenshots. Now, here you see, it looks like it's about to make a characteristic computer use agent mistake. This is not exactly a demo fail. This happens to me about 50% of the time. And so what's happening here? Date pickers are the bane of computer use agents. I mean, date pickers are the bane of humans, too. For the most part, we can't even figure out how these date pickers work. But what's happened here is actually a characteristic mistake that computer use agents make. The way that this one is working, the Responses API is using solely computer vision. So it's just looking at the screen and determining where to click. But what just happened there was that it clicked a couple of pixels off. Sometimes it misidentifies the bounding box of where it wants to click. And so it clicks on the wrong spot. And on a date picker, the month and the date and the year are separated by only a few pixels. So if you click in the wrong spot, which it can do, it might click in the wrong spot and type, therefore, in the wrong spot. And that's what it did. It started typing in the year before it started typing in the month. Now, it detected its error. I mean, you know, I have my little thought process showing up on the side here. So in this box over here, you can actually see what it was thinking all along. And somewhere in here, it figured it out. Well, I guess it didn't really, adjusting date format for delivery is how it put it. So it noticed that it made a mistake, and it fixed that mistake, and it usually does. But it gets me back to the fact that sometimes these CUAs are not so fast. So there are some folks that are really excited about potentially using these computer use agents in the contact center, for example. Because in the contact center, you may have like 10 different bespoke applications. And some of them are like Windows applications, some of them are browser applications, some of them are even green screen applications. The challenge with doing that is that it's not that fast. And so if you're the person on the other end of the line, you're talking to this contact center agent, and the agent is like, I need to stall. My computer use agent is trying to figure out the screen. So you have to be aware of that. So these can be super useful, but you have to be aware that certainly computer use agents of this type have their limitations with regard to speed and with regard to their accuracy. They will usually get there, but it takes a while. Now let's contrast this to a different type of computer use agent. Like I said, this one here uses solely vision. Now I'm going to spin this guy up, and let's take a look at what I'm telling this one to do. This one's a little different. So I'm going to tell it to find me a 3-pack of men's medium crew neck t-shirts, and I'm explicitly telling it to start with Nordstrom. Now this one here is called browser use. Let me bring up the browser behind it. Now browser use is an open source computer use agent. So you can get this yourself off of GitHub. It's browser-use. And browser use, so in the other instance, when I was using Operator, I have no choice but to use the Operator model, which is now Computer Use Preview. Here, you can choose your model. So in this case, I've connected it to my GPT-4o Mini model in Azure OpenAI. So that's what this is doing. And now it's coming to life. So behind it, you can see that it has made a new tab, and in a moment, it's going to start operating this tab. Browser use, being browser use, is limited in the sense that it can't use an entire computer. This can only use a browser. But that brings an advantage with it. And so in a moment here, as it starts to use this page, you're going to start to see some stuff happen. There it goes. See all those colorful little boxes over there? What's that about? Now, browser use is interesting because, well, it uses vision also, so it's sending these screenshots back and forth and back and forth. But because it is running in a browser, it also can rely on the fact that there is a page here, and that page has a DOM. It has a document object model, a structure, that it can use to determine its click targets. So those boxes are actually the click targets that are available on the page. And as a result, browser use makes many fewer pixel mistakes. So you don't see it make the same kind of mistakes as before. Now, I told it to start with Nordstrom. It got frustrated with Nordstrom. And it has left Nordstrom, and it's gone instead to Amazon. Well, this is how these agents work. Now, why did it go to Amazon? I don't know. I mean, this is what the model told it to do. Sometimes it goes to Google and searches it. Sometimes it just goes straight to Amazon. It's non-deterministic. It's going to do something different every time. That's the blessing and the curse of all agents, honestly, not just computer use agents, but all agents. They are non-deterministic. They make mistakes. They do things sometimes that you don't expect. And here we have it. It has gone to Amazon to go find my t-shirts, and it's making progress on this. Now, and eventually it will actually run this to ground. So eventually it's going to go find the t-shirts. I don't know if this is a 3-pack or not. And it'll add it to the cart. Now, in this case, this browser is a fresh new browser with no login. It has no Amazon credentials, so it'll only be able to get as far as adding it to the cart. It won't be able to just buy it. But this thing that you're looking at now, see, here at Build, and for the last few months, we have been talking everywhere about agents and agents and agents. We're constantly talking about agents. And most people have never seen or touched an AI agent before in their lives. So this is, to most people, just a theoretical exercise. What you see here, this type of agent, is most likely to be the first agent that your parents and your kids are actually going to touch for real. Because this thing, these browser use agents are coming to everything. Every OS, every browser, every phone, everything. In the next year, next time you go buy t-shirts or some commodity items, AAA batteries or something like that, you'll probably pull out your phone and you'll say, buy me a 3-pack of t-shirts, just like this thing did. So that is the near future for all of us. Now, I'm going to actually stop this before it really does buy me some t-shirts. So let me kill that. Now, some people ask, well, wait a minute, isn't that inefficient? Is it not inefficient for it to literally be clicking on the websites and stuff like that, websites that are designed for human use? Yes, that's true. Now, there are a couple of emerging standards that may help to mitigate that, and one of them is LLMs.txt. Another one, which I will readily admit that I still even haven't got my head around, is the NLWeb stuff that we announced yesterday. I think Jennifer knows more about it than I do, to be honest. But the idea of this, well, if you think about the way that these things work, like we were on Nordstrom before. I can go to Nordstrom.com there. Some of you may know that many sites expose these robots.txt files. And these little text files tell search indexers like Google what they can index and what they can't index. Well, by that same token, the proposal, which this one was actually written by our friends at Anthropic, is a similar concept, where it's this other hidden file that is a text file that can tell an agent, hey, if you're an agent, this is what my site is, this is what we do, this is what we have, and potentially even, here are some APIs that you can call if you want to do this more robustly than twiddling my website. And so in all likelihood, over the next year or so, as these computer use agents start to come to the fore and start to come into our consumer devices, as we start to use these things, there will be a period of agent optimization. It'll be kind of like search engine optimization, where everybody will be optimizing their sites and their phone applications for use with these agents. And this, or something like it, is very likely to be a part of that agent optimization. There is also probably going to be the notion of agent marketing. I mean, as I said, well, my agent chose Nordstrom because I told it to. I specifically said, start with Nordstrom. But then it got frustrated with Nordstrom, it moved on, and it went to Amazon. Why did it do that? Well, now my agent kind of did that more or less at random, not based on something that the model planned. But real agents that are in real production, there's likely to be a marketing component to that. It will be the rough equivalent of what we know as search engine marketing today. And so the agent, if you just say, book me a hotel in Seattle, and you don't specify what brand, then surely Marriott and Hilton and Hyatt and everybody will pay for placement in that agent on your phone or in your browser, wherever it might be. And it's not clear, by the way, that Google is going to be the incumbent in this space. I mean, there's going to be lots of providers. It's going to be like, for those of you who remember 1997? Remember all the search engines that used to use it, Lycos and Excite, Yahoo, and MSN? There were a million search engines back then, and if your search engine marketing dollars, you had to send them in all different directions. Well, it's going to be like that too, at least at first. At first, there's going to be all kinds of different agent providers. Every phone manufacturer that I've talked to is making an agent. Honor and Motorola and Samsung, everybody's doing it. I'm sure Apple's over there doing it quietly too. So they're all doing it now because they can own a piece of this pie, or at least they think they can. So that is going to be a thing. This is coming to a future near you. But one of the other questions that people often ask me, if we go back to where I was here, one of the other questions people often ask me is, they look at this and they're like, ooh, so does this mean that I can get rid of my RPA, my robotic process automation tool? People use these robotic process automation tools today to automate things like these applications, things that don't necessarily have APIs that they kind of have to click through it to do their automated testing or to do various things like in the contact center. Does this replace that RPA? And the answer is no. No, it does not, actually, because rule number one of agents, and this again applies not just to this type of agent, but to every agent, is anything that you can do deterministically, if you can code it or set out a workflow, do that. Do not rely on an agent to do something that you can do deterministically, because agents will make mistakes. And so if there's a process that you can automate with RPA, or partially automate with RPA, then do that, because it will happen deterministically, robustly, and it'll do the same thing every time. The agent, like this computer use agent, is good when you need reasoning, when you need it to read something, see something, reason out something. That is when you want to use a computer use agent. And in fact, RPAs and CUAs are friends. And now, to demonstrate that, I'd like to bring out the best of the best from Bucharest, the polymath from UiPath, Cosmin Voicu. There he is. Come on up, Cosmin.
Good to be here. Let me just put this back on. All right, agents. Pretty exciting stuff. So, yeah, funny in a way how both us and Microsoft kind of got to the same story about how these agents are supposed to work, basically by combining agents and UI automation. Okay, so I'm here to talk about how we see agents being used in enterprise automation. And a bit of a backstory, I work for UiPath. We have been doing, by the way, a show of hands, how many of you know what UiPath is and what we do? Okay, some of you do. So I'll keep this short. We do enterprise automation we've been doing enterprise automation for the past 10 years, and specifically UI automation for the past about 15 years. So UI automation is one of our core capabilities. We are the market leader for it. All in all, it's a pretty solid piece of technology. But as with any technology, there are definitely areas that can be improved. And this is where agents come in. This emerging technology promises to bring huge advantages in terms of reliability, ease of use, implementation time, and capabilities. Yes, so basically all of them better, faster, easier, and more. Full disclosure, we're not exactly there yet. As you've seen since these examples, there are downsides, but there are definite benefits that you can get today. Let's briefly get through them. So the first one is it lowers cost of ownership for automations. That means that is being done by agents making automations more reliable, so they break less often, so lower maintenance and cost for that. It also lowers the development barrier. That is not just marketing speak. It makes things easier, like all applications do. That's very serious for two reasons. First of all, the improvements in ease of use are massive. And the second is that we as a company take ease of use very seriously because we've seen how even minor improvements in ease of use actually increase automation adoption in companies. The third one is getting into even sexier territory by the fact that it enables tasks that were not previously viable due to high branching or complexity. One easy example to understand that is about Publicis, the advertising company, that had to enter the same data in hundreds of different websites. That was just not viable with RPA because they had to develop hundreds of automations, maintain them, and so on. That just didn't scale. The next one. This one, basically, this talks about how it enables tasks that were not previously even possible. It's basically agentic behavior like cognitive navigation and on-the-fly decision-making. That was not possible with classic RPA. And the last one, you've seen even in Marco's presentation, it unlocks a new set of scenarios on Linux, Macs, and so on to expand your automation footprint. So great, that's all well and good, but as with any technology, there are drawbacks. The main drawbacks are that these things are slow, expensive, and sometimes unpredictable on longer scenarios, much like our friend there. So what is our approach to all this? How do we get the benefits while avoiding the drawbacks? Well, we identified that the sweet spot for getting high reliability out of them, and high reliability is very important to us because we run unattended automations thousands of times per day and so on, and if one breaks, you have to go and fix it. So the sweet spot for getting high reliability out of them are microtasks. Microtasks are very short sequences of steps, so nothing like buy me those t-shirts from Amazon, more like a few clicks or a few types. This is where these agents actually get to the level of reliability that we need. The problem with this approach is that microtasks don't really make an automation. Microtasks are, small things. In order to get an automation, you need an enterprise-grade automation, you need a lot more than that. You need a way to chain together multiple microtasks that can make an end-to-end process. You need RPA and API automation where those are available. As Marco said, those are much preferable at this point in time. You need error handling, a development experience, and a lot of guardrails to keep these models in check, and most of all, a platform to run all this at scale. So all in all, we feel that the way to use this technology in production, unattended at scale, is through a platform such as ours. Basically, we give you access to all the best action models out there, deeply integrated into our platform so that you can get the benefits of that, and complemented by RPA and all the other automation tools so that you can pick and choose how you want to approach each automation scenario. Okay, so that's the short story I had. Let's take a look at some live demos. I have just 2 demos today. One is a bit more technical. Let me set things up a bit here. Okay. I hope it's going to work. All right, getting there. And a bit more. Sorry about that. Mirror. I think you should see everything right. Okay. Cool. So I have 2 demos. One is a bit more technical, and it shows you the ease of use improvements that I was saying were pretty huge. The other one is a bit cooler. It shows you something that was basically impossible until today. So the first scenario is an automation that sounds simple. Basically, you need to log into this website, and then let me zoom in a bit so you can see better. Okay, and then select the tickets that have the status open, priority high, and submitted today. Super easy to explain. Unfortunately, not very easy to do. So what does it look like? I have here demo of how it would look like today. So basically, I'm here in the UiPath development environment called Studio, and here it opens a new Chrome, the URL, that URL, types the username and password using, classic RPA, and this whole block is the old way of selecting the correct tasks as I described. And as you can see, so how it would work, you first have to extract this table, all of it, then filter it. To filter it, you have to basically do this, configure the filter to choose these values, and then output this table, and then for each row that remains in this table, extract the subject and configure a dynamic click based on that. So yeah, I won't get into that. I'm not sure how many of you could build that today, but I can just say that it's not for the uninitiated. So right, this is just commented out. It's ignored. Let's see how you would do all this thing with an agent. So basically, this will be ignored. So I will just add a new UI agent. Sorry, UI agent. I'm going to open the prompt and type this prompt. No? I'm going to copy and type this prompt, since you don't want me to spend this time. All right, so this prompt is saying, basically describing the task pretty much how I explained it to you. Click the checkboxes corresponding to the rows that have open and high priority, not also critical, because I've tried this before and it considers critical tickets also high priority, not necessarily wrong, from today. And I also gave it the date so that it knows what day is today. And that's all there is to it. Sorry, I canceled. Let me paste it again. Right, so once you do that, you also need to select the correct model. We have a bunch of them. Some of ours, which are actually similar to the browser used one that Marco was showing, but today we will use the OpenAI operator. And let's go back here to reset this, and let's try it out, hoping that it will work. By the way, all this is currently in private preview, so if you want to join that, feel free. And also that's like a caveat, hoping that these things work, and in case they don't, you know why. Okay, so it went pretty quickly and logged in. That was because that was done using classic RPA, which is super fast. And now it's analyzing this screen, trying to guess which are the tickets that are open and high from today. And there it goes. It found this. As you're looking at this, you see it's super slow. So that's one of the main points. If you can do it, that Marco also had, if you can do it deterministically, it's preferable, it's slower, it's faster and cheaper. All right, so yeah, basically we replaced all this thing with a prompt. So yeah, that makes things a lot easier. Okay, for the next example, this one's my favorite. This is a real use case from a customer of ours that I cannot name. Let's just say that they are a well-known CPU manufacturer. And the task was to test hundreds of games, actually not games, Fortnite versions for compatibility with their CPUs. Apparently there are hundreds of versions, mods and stuff, and so all that stuff, and they look similar but not identical. So you can see here one example. It has this play button, and here it's another play button. So basically the task was to start the game and then identify if it works. If it works, it's actually done in two methods. One is agentic. Basically, it looks at the screen and makes sure that it's not frozen and it works and so on. And another, let's say, some system commands that ensure that in the background that it's actually working. So yeah, these are some examples. As you can see, they're in different languages, different locations. So basically, you cannot use image automation. You cannot use text automation. It's just not doable today. All right, so let's see how an agent would do it. In order to test that, we've built a small thing. Basically, we gamified this task. So basically, I have here a browser where if you click here, it says denied, and if you click in the correct location, it says success. Great. So let's try it out. Just so you see how this is working, basically I have a list of all these games, and this automation goes deterministically through all of them, opens the correct URL, and for each one has this prompt. Click the play button. If there are multiple play buttons, because that's true, click the biggest one or whatever looks like the main one. And that's pretty much all there is to it. And let's run it, see how that works. All right, so it clicked the first one correctly. Then it opens the next one. Clicks, hopefully, this one correctly. Great. So as you can see, it can handle this task. It's not super fast, and it's not super cheap, but it's something that you just couldn't do before. Actually, this request of doing this thing was older than these agents. and this is the first time when we could actually accomplish it. I think this may be the last one, but anyway, all in all, it got all of them correctly. No, one more. Don't fail now. Awesome. Okay. That's about it. Thank you.
All right, thank you very much, Cosmin. All right,
Welcome.
well, I see we have a little bit over 3 minutes on the timer. So Jennifer, come on back up. We got time for one question. One question.
Good that all of us are here.
Anybody want to step up to the mic? Now is your chance. I should have told you that in advance. You could all have been thinking about your questions. Or, you could just leave the room. That's cool, too. Yeah, go ahead. Yeah.
What are the key differences in building these workflows in UiPath versus Copilot Studio?
What are the key differences in building these workflows in UiPath versus Copilot Studio? That's an interesting question. I mean, I think of Copilot Studio now as being more a designer for the agent itself. I mean, maybe the more correct analogy to make would be to Power Automate, actually, and building this with Power Automate, where you can actually set out the flow in that way. I mean, what do you think, Cosmin?
Yeah, I think the best answer would be for both of us to explain each side how that works. Basically, in UiPath, you've seen, you can just mix and match classic RPA with agents. I'm not exactly sure how you would do that in Microsoft.
Yeah, Copilot Studio has also just launched the ability to use this same CUA, the same one that I was using earlier, the Responses API, although it kind of creates the VM for you on a lot of stuff that Azure by itself doesn't do. But by and large, I mean, I would say that they're probably pretty similar. I don't know if they're necessarily as well integrated at the moment, at least with Power Automate and Copilot Studio, although it's probably going to get there. So, I mean, largely speaking, pretty similar in the long run, yes. All right, well, with that, I think we are about out of time. So thank you all very much for your time, and have a good day.
Thank you.